Alrighty, so we're going to be going over questions 15 through 17 on the pre-calculus test that you guys just had. So, starting off, number 15, which is the point of intersection for two equations. Alright, so we're given the two equations, x squared minus y equals 3, and y is equal to x plus 9. Now, whenever I'm given an equation, I like to put it in terms of y. So real quick, we can see that this one here is already in terms of y, and this one is not. So what we're going to do real quick is we're going to make this graph in terms of y. What the? Okay, I don't know why that just happened. Let's tone down the thickness there. There. Alrighty. So what we can do first is add y to both sides to get a positive y on the right, which gives us x squared x squared is equal to 3 plus y. Now I want to get the y on its own, so I'm going to subtract 3 from both sides, giving us x squared minus 3 equals y. I'm going to put the y on the left and the x squared minus 3 on the right just so that matches this equation here. Equals x squared minus 3. And now what I want to do to find the point of intersection for two equations is given at the point where f of x is equal to g of x. So really quickly, I'm going to rewrite these equations where f of x is equal to x plus 9, and g of x is equal to x squared minus 3. And once again, to find the point of intersection for two equations, you have to find when f of x is equal to g of x. So what we're going to do is we're going to set f of x equal to g of x. So x plus 9 is equal to x squared minus 3. Now what I see here is something I'd like to do. What we need to do here is we need to set all of this equal to 0. And to do that, we just need to move everything to one side. So we're first going to subtract x from both sides so that we get 9 is equal to x squared minus x minus 3. And then we're going to subtract 9 from both sides, which will give us 0 is equal to x squared minus x minus 12. And what you'll notice here is that this here can easily be reduced by using the what's it called? Oh, you're gonna have to give me a second here. I'm gonna pause real quick while I go figure out what this is called. So let me open up OBS and hit pause. Alrighty, we're back, and I just figured out it is called the quadratic formula. Don't know how I forgot that, but oh well. And now, as you know, the quadratic formula is equal to x is equal to negative b, where b is this term here, plus or minus the square root of b squared minus 4a, which is the term here, c, which is the term here, all over 2a. So to do the quadratic formula, all you have to do is plug in the coefficients of these values. So the coefficient here is 1, coefficient here is negative 1, and here it's negative 12. So we're going to plug that in real quick. So x is equal to negative 1 plus or minus the square root of b squared, which is just going to be 1, minus 4a, 4a being, we'll real quick, minus 4a c plus or minus, or sorry, all over 2a. Simplifying that all down, we get x is equal to 1 plus or minus the square root of 1 plus 48 all over 2. Now 1 plus 48 is just going to be 49. So the square root of 49 is 9. So this is going to be 1 plus or minus 9 all over 2. So doing the plus first, we get 1 plus 9 over 2, which is 10 over 2, which is 5. Then doing the minus case, 1 minus 9 over 2 is negative 8 over 2, which is, which is negative 4. So now we have our two x's where the graphs intersect, and to find our y's, all we have to do is plug in our x to one of the original equations. So I'm going to choose f of x here, so doing f of 5 is equal to 5 plus 9. Once again, we're using the x plus 9 case here. Therefore, f of 5 is equal to 14. And then f of negative 4 is going to be negative 4 plus 9, which is equal to 5. Therefore, our graphs intersect at 5, 14, and negative 4, 5. All right. And just to show that this works, we're going to go open up Desmos graphing calculator. And we're going to put in, real quick, let's see if I can just copy paste these, that'd be nice. Yep. Gonna have to make that x squared and make y equals x plus 9. So real quick here, we can see that they intersect at negative 3, 6, and 4, 13. Huh. X squared minus 3. Y equals x plus 9. X is equal to x plus 9. X squared minus 3. Subtract x from both sides. Subtract 9. And we get 5. 5 plus 9 is 14. Negative 4. So it should be negative 4. What? What am I getting wrong here? X plus 9, that intersects at 9. I add both sides, so we get squared plus 3, x squared minus 3, of course, and x plus 9. So why am I getting it wrong? X is equal to g of x, 3, 6. Subtract 9 from both sides. Because 0 is equal to x squared minus x minus 12. Is equal to negative b, which is positive 1, plus or minus the square root of b squared, which is positive 1, minus 4ac, negative 12, plus that all over 2a, gives us that 1 plus or minus 9, 2, plus 9 is equal to 10 over 2, which is 5, 1 minus 9 is equal to negative 8. What? What have I found then? 514. I'm going to get Discord call. I'm going to have to cancel that. 514. Where is 5? Sorry. 514. Huh. So clearly I'm doing something wrong here. Y is equal to x plus 9, x plus 9. Interesting. Let's try this the other way, where we make negative x squared plus x plus 12, which gives us x is equal to negative b plus or minus the square root of b squared minus plus 48 all over 2. This gives us 9 still. So adding the 9, we get 8 over 2 equals 4. Subtracting it, we get negative 5. Although that doesn't make sense. Negative 1 plus or minus 9 plus adding 9, we get 8. Subtracting it, we get negative 5 over 2. Except it's negative, so it's still negative 5, and this is still positive, which will give us the exact same thing. So what am I doing wrong here? We've got y is equal to x plus 9, and y is equal to x squared minus 3. I don't see anything wrong there. X squared minus 3. So why, when I have two graphs, am I getting a different answer from the math? You have to find when they equal each other, which is when they both equal 0. Both equal 0 at weird. Get this, 5 is equal to Alright, so yeah, that's entirely my fault that wasn't working, because there's this funny thing where the square root of 49 is in fact not 9, it is 7. Therefore, all of this is wrong. None of this here works. None of this over here works. Yeah, that's a problem. You could just factor it out, get x minus 4 and x plus 3. But with the quadratic formula, you want to make sure it's actually 1 plus or minus 7 over 2. That is a plus, not a 1. 1 plus or minus 7 over 2, which will get us 8 over 2 and negative 6 over 2, which gives us negative 3 and 4. So now, plugging those values into the equation, we will get f of x, or f of 4, for 4 plus 9, gets us 13. So our first point is at 4, 13. And then f of negative 3 gets us negative 3 plus 9, which is 6. Therefore, negative 3, 6 is our other point. Now we can go see we're validated here. The first point is at negative 3, 6. The next point is at 4, 13. So, yeah, when you're looking over your work, make sure you don't miss something like that where 9 is actually the square root of 81, not 49. That would be my bad. But yeah, here we just decided what makes negative 12. That's negative 4 and 3. And then what makes 1 here, the coefficient of 1. And once again, negative 4 plus 3 equals negative 1, giving us that coefficient. And then the two x's give us x squared. So that's that one. Please ignore all of this where I said 9. It's 7. That's my fault. But there we go. So moving on to number 16. Now number 16 and 17 are finding the x and y intercepts. So the first one, number 16, our equation is 2x squared minus 5x minus 12. So first things first, I'd like to factor this out, and it looks like to me, let's see, we need a 2x squared, so we need a 2x in the first column, and we have a minus here. I'd like to put the minus there, I suppose. We need 2x, let's see, 2x minus 3, and let's try x plus 4. Let's see if that works. So using our box method, we get 2x squared. So there's an x up here. Well, 2x. Let's just write this out. 2x minus 3, an x, and 4. This gives us negative 12 here. Negative 3x here. And right here it gives us 8x. So unfortunately, we're going to have to switch these. This is plus 4, and then this here is going to be minus 4 to get us what we need. So that will now give us minus 4 plus here, so that's plus 3x and minus 8x, which gives us 2x squared. Adding these together gives us minus 5x minus 12. So there we go. We know that our 2 points are at negative 3 and negative 4. Those are the zeros. Well, I suppose one of our zeros is actually 1.5, so 3/2. So 3/2 gives us our first zero, because when you're finding the x and y intercepts, you want to see when this whole thing will be equal to 0. So since we're doing that, we can see that our first x-intercept, I believe it's our x-intercept, will be at 3/2, and then our next one will be at 4. Now all we have to do is plug these two values into the equation to see when... Am I doing this right? Hold on. Yeah, okay. So I should probably explain this better. So to find your x-intercepts, you set the whole equation equal to 0, right? And then you factor it out to find when this side will be equal to 0, because that's when the whole thing will be equal to 0. And when the function is equal to 0, that will be when your x-intercepts, or where your x-intercepts are. So we know here, this is going to be negative 3/2, because to make this side of the equation 0, which will then multiply to this side of the equation and make it also be 0, we need negative 3/2, because negative 3/2 times 2 gives us negative 6/2, which is equal to negative 3, and negative 3 plus 3 is 0. For this side, all it is 4, because 4 minus 4 equals 0. So our first x-intercept, or our first x-intercepts are at 4, 0, and negative 3/2, 0. Now for our y-intercepts, all we have to do is set all of the x's equal to 0 in the equation. So we're going to set all the x's equal to 0, 2, 0 squared, minus 5, 0, minus 12. These cancel each other out, giving us minus 12 as our y-intercept. And we're actually not going to set that equal to 0, we're going to set it equal to y. So, there's a better way to explain this. So, when you're finding your x-intercept, right? You want to find when f of x is equal to 0. When you're finding your y-intercept, you want to find what f of 0 is. So that's how you find your y-intercept. You find when f of 0 is, and you find your x-intercept by checking what when f of x is equal to 0. So over here, all we were doing is finding when f of x is equal to 0, and when we were doing 2, 0 squared minus 5, 0 minus 12 equal to 0, that's what f of 0 is. And now we can go ahead and look at Desmos, and we can validate this. Hopefully it won't be wrong this time like last time. We're going to get rid of these. Of course, 2x squared. And we can see that our first x-intercept is at -1.5, or -3/2, and 4, 0. And our y-intercept is down here all the way at -12, thus validating our math. Now for number 17. We are given the equation, y is equal to x squared times the square root of x minus 4. So for x-intercepts, first thing we want to do is find when f of x is equal to 0. So what we're going to do is we're going to set this equation equal to 0. So 0 is equal to x squared times the square root of x minus 4. Now, what you could do is you could hypothetically distribute the x squared out into here and do some quadratic formula nonsense, or you can see that these two multiply to each other. So you can rewrite it as something like x squared times the square root of x minus 4. Therefore, this graph will equal 0 when either this term here is 0 or this term here is 0. So we want to find when that is. Now obviously with x squared is going to be 0 at 0. So our first x-intercept is going to be at 0, 0. Now this 0 we get obviously through setting this term equal to 0. Our next 0 will be found by setting this equal to 0. And you can see that's pretty easy. X minus 4 needs to be 0. X minus 4, well, x minus 4 equals 0 if you do some algebra. X, you add 4 to both sides, you get x minus 4 equals 0, add x equals 4. Therefore, our next 0 is at 4, 0. Now for our next one, remember, the y-intercept is found by setting f of 0 finding f of 0. So we're going to plug in 0 to all the terms. Times the square root of 0 minus 4, which gives us f of 0 is equal to the square root of -4. Now, that's kind of a problem. Kind of like a big problem. Because the square root of -4 doesn't technically exist on a two-dimensional plane, because you can't multiply something by itself to get a negative number. That's not how it works. You can't do a negative times a negative to get a positive. Like -2 times -2 equals 4. 2 times 2 equals 4. So let's look at this real quick. But what I think it is, right? There's this term, I. I don't know if you guys have learned about I, but I is equal to the square root of -1. It's basically I as in it's an imaginary number. So what we can do here, and I'm going to validate this real quick. Okay. So I believe that this is going to be 2i, because it's not going to be 4i, because the 2 here refers to its square. So basically, if you square the positive value here, you would get 2. You would actually just get 2. So if you wanted the square root to be, or if you wanted it to be 4i, you would need to square root -16 equals 4i. But the square root of -4 is equal to 2i. So this is going to be weird, but I believe the y-intercept is at 2i, or sorry, it's going to be at 0, 2i. Let's go see if this validates. This checks out. X squared times the square root of x minus 4. And there you go. You get something really weird. This is really weird. So we have our first one at 4, 0. And then I suppose we have an imaginary 0 at 0, 0. So what's likely going on here is that we have an x-intercept at 0, 0 in the imaginary plane, and then we have our y-intercept in the imaginary plane of 2i. I'm going to go real quick check this. So I'll pause real quick. I'll be back. Alrighty. So there was something I completely forgot to do, which I should have done with both. So we're going to go over that real quick right now. So we're going to get rid of everything we did here, because it's all technically wrong. So, wow, this eraser really could be bigger, but can I just, like, take this, delete? Perfect, okay. So the first thing you need to do when finding x and y intercepts is to first determine when you're going to have extraneous variables. And you do that by seeing when the graph exists. So the easiest way to do this for especially this one is to say that the square root of x minus 4, right? That is a graph. If we take y equals the square root of x minus 4, we're going to get a graph that looks something like this, starting at x equals 4 and y equals 0. So we know, right, the graph does not exist beyond that point. So it starts at 4 and goes no further back than 4. Therefore, when we're doing this, right, we're going to set everything equal to 0. 0 equals x squared times the square root of x minus 4. Now, had a graph existed at 0, then we could set this equal to 0, and we'd have an intercept at 0, 0. However, the graph does not exist at 0. If we go back here, this is 3, 2, 1, 0. At x equals 0, there is no graph. Therefore, you cannot have an x-intercept there. However, there is an x-intercept at 4. Therefore, we have one x-intercept at 4, 0, because it sets that equal to 0. And it exists in the domain. So, when we're setting x equals to 0 to find our y-intercept, we know that x must be greater than. So x is greater than or equal to 4. That is a must. X does not exist. Like, it is not less than 3. Sorry, x is not less than 4. Therefore, we cannot have a single x value, or y value for that matter, behind x equals 4. Therefore, when we set the f equal to 0, nothing there exists. Therefore, we cannot have a y-intercept. And this is validated by the graph right here. As you can see, it will never cross the y-intercept. So, real quick, I'm going to give us another problem like this. We'll call it 17.5. Make sure you find your domain at all times. So we're going to do y equals, let's do x cubed, and then square root of x minus 2. So once again, find f of x equals to 0. So x cubed equals x minus 2. Now before we solve,
Reading.
x cubed equals x cubed times the square root of x minus 2 is equal to 0. Before we solve this, find the domain. This is our function. This is our restricting function, because if this goes negative, then we don't have a graph. So this becomes negative at anywhere less than 2. So at 2, it's 0. Therefore, by the way, we just found one of our x-intercepts at 2, 0, because that sets this equal to 0. Now, 0 sets this equal to 0. However, our domain, once again, is 2. Therefore, nothing can be behind 2. Therefore, 0 cannot be our value. And since 0 cannot be our value, we also do not have a y-intercept. So that's all for today. Quick 30-minute lesson. Probably could have been cut down if I didn't make a mistake up here where, you know, square root of 49 is not 9, it's 7. And over here could have been a little shorter if I realized that you have to find your domain first. But there you go. I'm going to show the whole thing real quick. I'm not sure how well you can read that, but you can pause here and just look over. Sorry for the confusingness. And yeah, good luck.